Hello everyone, welcome to my channel. Today, let's learn to write a program in Java to check whether a given number is a prime number or not. What kind of numbers are called as prime numbers? Numbers which are having only two factors are called as prime numbers. Numbers which are having more than two factors are called as composite numbers. For example, let's take the value of n as 17. We know that 17 has only two factors, 1 and 17. So 17 is a prime number. Let's take another example. Say n is equal to 18. When we find the factors of 18, we get 1, 2, 3, 6, 9 and 18 as the factors of 18. So 18 has more than two factors. So 18 is not a prime number. 18 is a composite number. Now, let's look at the algorithm to solve this problem. The first step is to input the value for n. Next, we have to count how many factors n has. So, to count the total number of factors of n, let's declare a variable and initialize it as 0. Let count is equal to 0. Now, to find out the factors of n, take all the numbers from 1 to n and divide n by each number. So, to take all the numbers from 1 to n, we have to use a looping structure. For loop will be the most suitable looping structure for this purpose. For I is equal to 1 to n. Check the divisibility of n by each value of I. If n modulus I is equal to 0, if n is divisible by I, that means that I is a factor of n. Then increase the count by 1. Repeat the process till the value of I becomes n. Repeat through step 3 till I becomes n. When the loop completes its iteration, you will have the total number of factors of n in count. Now, check the value of count. If count is equal to 2, n is a prime number. Otherwise, n is a composite number. Now, let's convert this algorithm to a Java program. The first step is to open the scanner class from utility package of Java. So, import java.util.scanner. The next step is we have opened the class, public class, prime number. A meaningful name is given to the class. Body of the class is opened here. All the executable commands in Java are written inside a method. So a method is opened here. Public static void is prime. A meaningful name is given to the method is prime, as we are going to check whether an entered number is a prime number or not. Any name can be given for the method. Sufficient number of variables are declared here at the beginning of the method. In the end, to store the input from the user, as we have to use a loop index variable I, and to store the total number of factors of n, variable count is declared and initialized as 0. Now, scanner class object is created to accept the input from the user. Scanner type sc is equal to new scanner system.in. An interactive message is given to the user through the command system.out.println, enter a number. To accept the input from the keyboard, nextInt method of the scanner class is used. N is equal to sc.nextInt. Now, let's count the factors of n to check whether n is a prime number or not. For this purpose, let's use a for loop. The for loop's index variable started with 1. I is equal to 1. Value of I goes till n. I less than or equal to n. Each time the value of the index variable is incremented by 1 plus I. Inside the for loop's body, we have given the command to check whether n is divisible by the value of I. If n modulus I is equal to 0, I is a factor of n. So, increase the count variable by 1. Let's see how this for loop works with an input value. Let's take a small number n as 5 to see the dry run of this for loop. As the control comes to the for loop, the initial value of I is set as 1. After the initialization, the test expression will be evaluated to decide whether the loop has to go for the iteration or not. I less than or equal to 5. Value of n is 5. As the test expression is evaluated to true, control enters into the loop's body to execute its statements. If n modulus I, n 5, 5 modulus 1, 5 modulus 1 is equal to 0, test expression is evaluated. 5 modulus 1, modulus operator will divide the given number 5 by 1 and the remainder of the division will be returned as the result. 5 modulus 1 is equal to 0. Yes, 5 is completely divisible by 1. So 5 modulus 1 is equal to 0. It is evaluated to true. As the test expression, as the condition is evaluated to true, count is incremented by 1. As 1 is a factor of 5, we have to increase the count variable by 1. So count is incremented by 1. Initial value of count was 0. Now the closing of the for loop's body is seen. So control returns back to the header line of the for loop's body to update the value of the index variable. Now the value of the index variable I will be updated to 2. It is incremented by 1. Test expression is evaluated to decide whether the loop's body has to be executed or not. 2 less than or equal to 5. Test expression is evaluated to true. So control again enters into the body of the for loop. Now n modulus I, the current value of I is 2. 5 modulus 2 equal to 0. No. Test expression is evaluated to false. Condition is evaluated to false. 2 is not a factor of 5. So count will not be incremented. As the closing of the for loop's body, control returns back to the updation statement. Value of I is incremented to 3. 3 less than or equal to 5. True. So control again enters into the loop's body. Now n modulus I is equal to 0. 5 modulus current value of I is 3. 5 modulus 3 equal to 0. 5 is not divisible by 3. So 3 is not a factor of 5. 5 modulus 3 is not equal to 0. Test expression is evaluated to false. Count will not be incremented. As the closing of the loop's body is seen, control resumes back to the updation statement. Value of I is updated to 4. Test expression is evaluated. 4 less than or equal to 5. Yes, 4 is less than 5. Test expression is evaluated to true. So control enters into the for loop's body to execute the statements given inside. Now n modulus I is equal to 0. Value of n is 5. 5 modulus 4 is equal to 0. 5 is not divisible by 4. 5 modulus 4 is not equal to 0. 4 is not a factor of 5. So count will not be incremented. Control goes to the updation statement again. Value of I is incremented to 5. 5 less than or equal to 5. 5 is not less than 5, but 5 is equal to 5. Test expression is evaluated to true. So control again enters into the for loop's body. At this point of time, 5 will be divided by 5. 5 modulus 5 is equal to 0. Yes, 5 is completely divisible by 5. The condition is evaluated to true. So, the statement given after the if clause will be executed. Plus plus count. 5 is a factor of 5. So, count is incremented by 1. The current value of count is 2. At present, count has the value 2. As the closing of the loop's body is seen, control resumes back to the updation statement. Plus plus I. Value of I is updated to 6. 6 less than or equal to 5. False. Control, that as the test expression is evaluated to false, control goes out of the for loop to execute the following statements. Now the value in count is 2. So now we have to check whether the value in count is equal to 2 or not. If count is equal to 2 means n has only 2 factors. If n has only 2 factors, n is a prime number. Display that system.out.println n is a prime number. Otherwise, n is not a prime number will be displayed. As now count has the value 2, 5 is a prime number. Now let's take one more example. say the value of n is equal to 4. So let's see how this for loop functions with the value of n as 4. The loop index variable I started with the value 1. Test expression is evaluated 1 less than or is equal to 4. It is evaluated to true. So control enters into the for loop's body. Current value of n is 4. 4 modulus the value of I is 1. 4 modulus 1 is equal to 0. Test expression is evaluated to true. So 4 is completely divisible by 1. So the count variable is incremented by 1. Initial value of count is 1. As the closing of the for loop's body is encountered, control resumes back to the updation statement of the for loop to update the value of loop index variable I by 1. Now the value of I is incremented to 2. 2 less than or equal to 4. True. Control again enters into the loop's body. 4 modulus 2 is equal to 0. Yes, 4 is divisible by 2. So 2 is a factor of 4. Count is incremented by 1. Count is incremented by 1. Closing of the loop's body is seen. Control resumes to the updation statement. Value of I is updated to 3. 3 less than or equal to 4. True. So again control enters into the loop's body. 4 is divided by 3. 4 modulus 3 is equal to 0. False. 4 is not completely divisible by 3. So test expression is evaluated to false. The remainder of the division is not equal to 0. So count will not be incremented. 3 is not a factor of 4. Again, the value of I is incremented. Value of I is incremented to 4. 4 less than or equal to 4. 4 is equal to 4. So control again enters into the loop's body. Current value of I is 4. 4 modulus 4 is equal to 0. True. Test expression is evaluated to true. So 4 is a factor of n, that is 4. Count is incremented by 1. Control goes to the beginning of the for loop. For the updation statement, value of I is updated to 5. 5 less than or is equal to 4. Test expression is evaluated to false. So control goes out of the loop to execute the following statements. Now the value in count is 3. Count was updated thrice. So count is equal to, if count is equal to 2, then the entered number will be a prime number. The value in n is 4. Count is 3. If the value in count is equal to 2, the entered number will be a prime number. The value in count is 3. 3 equal to 2, false. So n is not a prime number. 4 is not a prime number. 4 is a composite number as it has more than 2 factors. Thank you for watching. For more videos, like, share and subscribe my channel.